Today we're going to be talking about Lesson 4, Solving Special Systems of Equations. So up until this point, the systems of equations that we have seen have one solution. So the lines intersect at one point. Yesterday, we briefly talked about one question that had no solution. So when the two lines are parallel, they have no solution because the lines will never meet or cross. The third special case is infinitely many solutions. So when the two lines are actually the exact same, they're infinitely many solutions because they cross or touch an infinite number of times. I've also included here at the bottom the different methods that we've talked about for Chapter 5 and when we should be using them. So far we've talked about graphing, substitution, and elimination in two different cases. Today we're going to use those methods to help us solve these problems. So you can use any of those methods. Most of these I would recommend using either the substitution or the elimination method. So starting here, since this is solved for a single variable, I'm going to use the substitution method. So I'm going to substitute the first equation into the y variable in the second equation. So negative x plus 3 equals negative x plus 5. Now I can start by solving this. I want to get all the variables to one side of the equal sign. So I'm going to add x to both sides. When we do that, negative x plus x cancels. We're left with 3. Negative x plus x cancels. We're left with 5. Since we know that 3 does not equal 5, the answer to this system would be no solution because there are no ways that 3 is equal to 5. Now, on the next one, go ahead and try to solve this one using substitution. We should have taken the expression from the first equation and plugged it into the y in the second equation. So we can rewrite it as 5x minus 5x minus 2 equals 0. 5x minus 5x is 0. Minus 2 equals 0. 0 minus 2 is negative 2. We know that negative 2 does not equal 0. So again, this is no solution. With this third one, same thing. Solved for a single variable, so we can use substitution. So for x, we are going to use 2y plus 10. So 2 times 2y plus 10 plus 3y equals negative 1. 2 times 2y is 4y. 2 times 10 is 20. Plus 3y equals negative 1. 4y and 3y make 7y. We can subtract 20 from both sides. Here we find that 7y equals negative 21. So y equals negative 3. Since y equals negative 3, we need to plug that back into that first equation. So x equals 2 times negative 3 plus 10. 2 times negative 3 is negative 6 plus 10 is 4. So here we have one solution of 4, negative 3. So when we graph these two equations, they would meet or cross at 4, negative 3. Now, looking at the next three examples, these are going to be best suited for elimination. So we can see here that the y's have opposite signs. So we can eliminate those. Plus y minus y cancels. X plus x is 2x. 3 minus 3 is 0. We can solve for x by dividing by 2 to find that x is 0. When we plug in 0 for x, we find that y is 3. So again, this one will have one solution at 0, 3. With number 5, we can see that we do not have an exact opposite here. So I'm going to try to get my 2x to be the opposite of 4x. So I know that if I multiply everything in this equation by -2, -2 times 2x is -4x. These are now opposites. -2 times y is -2y. -2 times 5 is -10. I can then use my elimination method to solve the equation. So 4x minus 4x is 0. 2y minus 2y is 0. They cancel each other out. 0 minus 10 is -10. So here at 0 equals -10, I know that that is not true. So again, this is no solution. In number 6, I see that we have opposite signs, but our coefficients do not match. So I need to make my coefficients the same. I know that 2 times 6 will make 12, so I'm going to multiply everything in this top equation by 6. 6 times 2x is 12x. 6 times -4y is -24y. 6 times 10 is 60. I can then use my elimination method to solve. So -12x plus 12x cancels and is a 0. 24y minus 24y cancels and is a 0. -60 plus 60 cancels and is a 0. So here we can see that 0 equals 0. We know that this is always going to be the case. No matter what, 0 always equals 0. So when the value on both sides of the equal sign is the same, it's always going to be true. So this answer is infinitely many solutions. Infinitely many solutions. So it means that both equations are the exact same line.